to Automated Software Engineering, NC State University, Fall 2015, recorded Lecture 1. As always, we start at tinycc/mace, and here's the home page of the subject. And today's lecture is about the reading assignment described here as read 1, 2, 3, 4, 5, 6, 7, 8, 9. This assignment is about how to read papers. Why does anyone want to read a paper? Well, the technologies that we're studying right now are not static. They're going to change a lot over time. And so our question we have to ask ourselves is, how can we learn to keep up more with more technologies? Now, it turns out reading papers are a way to understand emergent fields. But when beginners try to read complex research papers, it can take them an awful long time to read their first paper. After a while, they're getting pretty good at it. But what we'd like to be able to do is assist people who aren't experienced at reading research papers to learn how to read research papers faster. So this page is a set of lecture notes on the theory behind the structure of a research paper, and it's a set of assignments that lets students practice those skills in reading lots of papers. There's two audiences I know for this lecture. One is Dr. Murphy Hill's CS510 group, and they're going to do a fast path assignment where they do parts 1 and 2 of the assignments down here. And the other audience, the CS 591 and 691, 791, and I'm not sure about those numbers actually, are going to do a more advanced assignment, jumping around larger. And the fast path newbie assignment in CS510 will be a few weeks, and the longer assignment will be something done each week, building up to a big essay at the end of the semester. So let's start first with some theory, how to read papers faster. Now, the premise of what I'm saying to you is, if you want to understand how to read papers faster, you have to understand what the writers are trying to do. And that means understanding the rhetorical strategies of the paper. Another reason I can read papers faster than you can, perhaps, is I have some understanding of the terminology being described in the paper, and also I might know more about the historical context, what happened before this paper and what happened after this paper. Also, I know a trick called feature extraction. It turns out when experts look at something they're expert about, they don't read everything. They pick out the things that matter to them the most. Let's talk about that last point a bit more, feature extraction. And to work that out, to talk about that, let's look at this little skate over here. Now, a skate is a mechanical device, and there are many mechanical devices: cars, refrigerators, ovens, and skates. We can talk about them all separately, we can think about them all separately, but experienced mechanics know that all these devices have similar sections within them. They might all have screws, they might all have wheels. And so when we look at these devices, we can understand them faster if we pull them apart into their sections. If we can explode seemingly complex things into their various parts, which, by the way, and this is the really useful thing, we could repurpose them for other areas. When we read a paper, we're really trying to map out its internal structure, not to perhaps understand the entirety of the paper, but to learn what parts of the paper we might be able to extract for our own purposes. Sometimes I think that we don't write papers for repeatability, to have other people repeat an entire study. In software engineering, it's very rare that people are motivated to repeat an entire previous study based on a prior technology. But often when I read a paper, I find a technique and think, oh, that's useful. I could try that in my next work. So I read papers to find the little bits that I really want to use, and then I take them away and I use them. So I don't really read thoroughly over papers. I read them looking for parts. Now, what might be the parts we find in a paper? Well, somewhere in the beginning that there might be some motivational statement, a statement of why anyone is actually interested in this. The paper might contain a bunch of hypotheses. It might even list them. The hypotheses of this paper are. Papers might contain checklists. There might be a section called related work, where the paper author tries to demonstrate their scholarship and understanding of the field. There might be a set of study instruments, lists of best way to ask questions, best ways to handle certain qualitative factors. There might be some interesting notes on statistical tests, how to compare populations. There might be some commentary about the scripts used in the analysis. There might be some informative visualizations, and this point 8 is rather interesting. Sometimes when I read papers, I look at the way people present the output and go, oh, I really need to copy that. That's a nice way to present something. Sometimes paper offer baseline results. One of my most famous papers began with, this paper is trying to offer a baseline result that I hope a community goes forth and does better on. Some papers describe good ways to sample certain populations. Some papers offer patterns, best practices for performing things. Some papers offer anti-patterns, worst ways to do things, and both are useful. Some papers, not too many, and we hope to see more of these in the future. Some papers offer negative results, like I tried something and something didn't work. Some papers sometimes take the time and the care to walk the beginner through some tutorial notes. Papers offer sometimes some new results. Paper comments on future work, and future work is particularly interesting. It's the motivator that you read the paper and go, oh, someone needs to do that, why not me? Now, some things in papers are actually bigger than papers. Sometimes papers say, I used a particular data set, and this is very interesting. To do similar work, you want to access the same data. The data may not be in the paper, but the paper may point to some website where anyone can access that paper. Similarly, the paper might say, most of my code is up on some GitHub repository. So if you want to start reading a paper or working on the same task as that paper, you can go to the GitHub and grab it. Some papers aren't based on data, but based on models. The formal reasoning people have a large suite of models, and in automated software engineering, in search-based software engineering, there are many standard models people use to baseline their tools. Some people also have delivery tools, such as config management tools that let you build the system from scratch, some sort of makefile, some sort of package management system, which lets you update things, and some people even take their entire analysis, burn it into a virtual machine, and offer you the entire ISO file. So that means you can literally pick it up and you can run it instantly. These are all things we might want to extract from a paper. These are all things we might want to use separately. Moving on to rhetorical strategies, it turns out when people write papers, they do it in different ways. They might comment on any of the items shown above. There also might be a comment on the thesis being investigated. Some papers are very clear on the contribution of what they're saying. Hopefully papers describe how they're going to investigate things. Papers might make some comment which might be egotistical on the power and the applicability of the results. Some papers might discuss summaries of technical development done with this, and some people might offer details about some examples. So when we first read a paper, what's useful is to read the abstract, which is the short text at the front, skim over the pictures, tables, graphs, and diagrams just to get the big picture, see if in that skim you can find any of the items listed above, then have a quick peek at the references to see whether this person's working in a field that you know. Another rhetorical device is to do with the goals of the paper. Now, some papers have different goals, and Swales talks about a 3-move model. Now, the following is an empirically derived model, and it describes how real-world research articles are typically begun. These aren't rules. Papers can do different things here, but this is just things to look for. different ways people can open a paper. And what Swales talks about is 3 moves. And Swales' first move is establishing a territory, which is an opening move. A writer might want to broadly sketch out the big paper, point out the importance of a general subject, and make generalizations about the subject. There may not be new results in such a establishing a territory move. Another thing a paper might want to do is establish a niche within a territory. So if another paper has done move 1, establish some territory, a second author might come along and say, within the big challenge statement offered by that previous work, I'm trying to build a little niche here in this corner of the paper. They might make a counterclaim. They might indicate a gap in all the thinking about the territory being discussed. They might raise some question that needs to be addressed. They might suggest the work is continuing in some tradition. And another move, which is even more detailed than establishing a territory or establishing a niche, is occupying a niche. And this way, they're going to really move in and sort of take ownership. They're going to outline some purpose. They're going to state some principal findings, and they're going to say exactly what they're going to do here. And so papers do different things. Some big vision papers are about establishing territories. Some subsequent papers establish some sub-region, a niche in that territory. And some papers try to say, I am the expert in a particular niche. Not all papers do everything. We see more of move 3 than move 2 and 1, but be aware that not all papers are the same. So moving on from the moves we have in opening a paper, let's talk about employing the above ideas, putting theory into practice. And again, I stress that if you're going to spend some time as beginners reading research papers, you might be somewhat sad after reading your first paper because it might take you a bit of time. Bear with it. Reading a paper is an important skill that you're going to have to learn if you want to keep up with the literature, and there are tricks and tips for learning how to read papers faster. One of them is learning the historical context. Now we're going to talk about the details of these assignments here, and anything in italics is explained below. So first we're going to find a paper called 1, and we're going to establish its historical context by working backwards in time and looking for papers 2, 3, 4, 5 that are the historical precursors to 1. So what we're going to do is, first, you're going to find a source of highly cited papers that everyone is reading, just so that your life isn't too complicated. Don't go for a paper from your own institution. So don't think you have to review the lecturer's papers. If you're a student of general software engineering, you might want to look at paper proceedings from the International Conference on Software Engineering. And if you're a student of automated software engineering, you might want to start with the International Conference on Automated Software Engineering. And if we just go to that particular page, what you're looking at here is Google Scholar's listing of the 50 most cited papers at automated software engineering in the last 9 years. So last 5 years. So what I suggest you do is you're going to start in 2011. And there's a reason we're going to start in 2011. I'll talk about that in just a second. But find some paper that interests you, like this one, towards more accurate retrieval of duplicate bug reports, that's received 71 citations since 2011. Now, 71 citations in 4 years is a big deal. Most papers get 1 or 2 citations. So these are a bunch of standout publications. So if we go to that paper, we can then say this is our baseline paper. And that's what we're going to call 1. And what we're going to do is we're going to summarize its parts. And I'll show what that means in just a second. Now, the reason we're going to start in 2011 is that we're going to go backwards in time, back to 2008, and look at what papers came before it. And we're also going to go forward in time to 2015 to see what happened to that work subsequently. So in this first part, learning historical context, we're going to go backwards in time, papers that date between 2008 and 2010 that are mentioned in the reference list of this first paper, this paper 1. And we want them to be highly cited, and I'll show you how to find out the highly cited papers. And then I want you to summarize some of their parts. Okay, now summarize some of their parts, we mean write about 500 to 1,000 words describing them. Now, this whole document you see in front of you, this whole page, is 1,000 words. So 500 words is not much to write. When you summarize its parts, make sure you start with a good reference up the top so people know where it's from. Write down the 4 most important keywords in the paper, plus a 2-line definition of each. Initially, don't worry if you get those definitions wrong. Just make a guess. Maybe do a little bit of Wikipedia reading, maybe look around, Google the name, but see what you think are the best ways to define the 4 most important terms in the paper. Find 4 of that big list, 1 through 19, shown above in the paper. And I'm just going to scroll up and remind you what I mean by 1 through 19. So if you scroll up once, twice, 3 times, 4 times, 5 times, remember this big list here of 19 things? You don't have to, again, I stress, you don't have to find all 19 in each paper. You're just looking around for about, scrolling down, scrolling down, scrolling down, just 4 of them. And you're writing a few notes on each. Also, be critical. Write down 3 ways the paper can be improved. And that is what you have to do for paper 1. Now, once you finish that, then in my automated software engineering subject, that's the entire task for week 1. For the software engineering subject, I think Dr. Murphy-Hill is going to ask people to do paper 1, 2, and 3 in week 1 and carry on after that. But for automated software engineering, that is the entire task for week 1. Go to some place where you can find highly cited papers, find a highly cited paper, and write some notes on it. So coming back to the assignment spec, for the subsequent papers, 2, 3, 4, 5, etc., comment on the connection to the other papers. Your goal is to generate this summary in about 30 minutes, and it's not going to happen the first time through. You're going to have to read numerous papers before you get good at reading papers. Okay, now how do you find highly cited papers? Well, one way is to use Google Scholar. If you go to scholar.google.com or the ACM Digital Library or IEEE Explorer, and if you type in, for example, mining metrics to predict component failure, which happens to be a title of a paper, you end up with the paper shown here. Now, if you look down here, you can see cited by 527, which is a highly cited paper. So if the paper you're reading references 10, 20 papers, you can very quickly find how many citations those papers have, and then you can find highly cited papers that came before this one. Now, if you click on that cited by 527, you can see all the papers that cited mining metrics to predict component failure. And they're sorted approximately by citation. though Google does some funny things with this order. And here are the most cited papers in the past that referenced mining metrics to predict component failures. And it turns out that mining metrics to predict component failures, it was cited by predicting defects for Eclipse 398 times in 2007. And it's cited just a moment please. This was cited by 527 papers. This is a 2006 paper. And so down you see here that was cited by a paper in 2007, cited by a paper in 2008, cited by another paper in 2007, and you can see these are also highly cited articles. So using these tools, you can walk backwards and forwards through time. To find the highest cited paper, that cite the week 1 paper, look up your week 1 paper in scholar.google.com and count their citations. Okay, so that's the exercise for running through 4 or 5 papers. Go to a highly cited paper in 2011, then work backwards in time and perform the above. Now that's part 1 of the assignment. Part 2 is, now you know how to read papers, identify reusable data in that paper for which we could grab the data and store it. It turns out we have some active people collecting the data from papers. What you're looking at now is the Terra Promise repository for software engineering, and this is a place where you can store lots of data. And if you look on the left-hand side, you can see dozens and dozens of data sets. This is a large and active repository. It has things like thousands of spreadsheets and many other data items from many other software projects. Now what you're looking at here is the donation sheet at Promise. And what people do is they find papers and say, we really want to take the data from that paper and put it into Promise. And you can see a set of questions describing what we need to add things into Promise. And each one of these suggested name of data set, suggested category, etc., etc. Down the bottom here has got notes on all the above. So if you get stuck, you can read the notes. So for the first couple of weeks in the assignment shown here, you're going to read papers. And once you know how to read papers very well, you're going to read a paper in part 2, identifying if any of the papers you've read have got reusable data that can be added to Promise. Now, it may be that your kind of papers don't have reusable data. Certain formal analysis papers, certain speculation papers, certain Move 1 type papers that are establishing a territory but don't have results yet, may not have paper data added into Promise. That's okay. If you can't find data in any of the papers you've read so far, just write a note explaining why your kinds of papers don't have that sort of thing. Okay, now we're going to go on to part 3 of the reading assignment. And for students in automated software engineering, we're now 5-6 weeks into the future. For students of Dr. Murphy Hill's software engineering, you don't get to part 3. This is not your problem. So you can actually stop the video right here if you want. So the students of 510 left us, and are we left with just the automated software engineering people? Oh good, let's carry on. Now recall what happened in part 1. We went to 2011 and we walked backwards in time. In part 3, we go to 2011 and walk forward in time. We try to find 3 papers, 7, 8, 9, that cite the paper we found in week 1, that date 2012 to 2015, that are highly cited. I've shown you how to find something highly cited, and you summarize their parts. And that's it. It's exactly the same as part 1, but instead of reading the papers that preceded the paper you're studying, you're reading the papers that follow it. So what you're trying to learn is the historical context around a paper. Finally, at the end of the semester, I want you to write one big essay that talks about the procession of research in that area for the automated software engineering task you're working with. And there's some information here about what I'm expecting in terms of size, etc. And there's a format I want you to follow when preparing the report. And there's also some hints here on how to get full marks. But the main thing I want to stress here is that you're not getting to this big essay until week 11, 12, 13 of the semester. And by that time, you might find that the paper you started with way back this week, paper 1 from 2011, was a little bit dull somehow. In which case, feel free to start again. If it turns out you don't think there's much you really want to say about the sequence of 8 papers that you've been reading that started in 2011, that went back to 2008 and go forward to 2015, just start again. Find another paper from 2011, go forwards, go back, and it turns out that by the time you've done everything in this page down to here, it'll be a day or so's work for you to pick up a bunch of papers and read them quickly. So that's the assignment. If you have any questions, email tim.menzies@gmail.com or the subject website. Thank you for your time.